For people who don't like the cold, winter is really miserable. And here in the Arctic, it can be even more brutal. But the Arctic, and where you live, worlds apart, may be more connected than you might think. Scientists are finding that as temperatures in the Arctic rise, changes here may be contributing to extreme weather thousands of miles away. Temperatures are rising across the world, but the warming is strongest in the Arctic. Here the warming is twice as fast as the global average. And that's causing the ice to vanish. In less than 4 decades, the Arctic has lost 3/4 of its sea ice. It covers a third less of the ocean than it did just 20 years ago. That's drawn interest from an international group of researchers who have come north to understand how the Arctic is rapidly changing. These changes create a nasty feedback loop. First, the ice melts, turning reflective surface into a dark one that absorbs solar energy, warming up. Without the ice, more water evaporates, contributing to larger amounts of greenhouse gases. And all that extra heat has had surprising effects. The process begins high in the atmosphere. Earth's air tends to move from the warm middle of the planet to the poles. Because warm air takes up more space, it's taller, so gravity pulls it towards the Arctic where the atmosphere is thinner and shorter, and this creates wind. The Earth is spinning, so instead a river of air known as the jet stream is formed moving west to east. This is what the polar jet stream looks like. You can see the patterns of its winds. The jet stream serves as a boundary between cold air from the Arctic and warm air from the tropics, and its shape influences weather patterns. The Arctic atmosphere is changing as the temperatures rise there faster than further south. There's less gravitational pull on the air towards the North Pole, so the jet stream slows down. Less of a flow, and the jet stream is losing steam. When it's curvy, weather sticks around longer, causing bigger storms, droughts, and cold spells. Some scientists think that's supercharging extreme weather across the world. From the Helmer Hansen, I call atmospheric scientist Jennifer Francis, who explains how the polar jet stream affected the U.S. this past winter.
There was a huge northward swing in the jet stream over the west coast, bringing lots of warm air to Alaska.
It's been the hottest December on record, with most temperatures 20 to 30 degrees above average.
And then the jet stream took a big southward dive over the Rockies and dipped way down into Florida.
We haven't seen measurable snow in Tallahassee in over 30 years.
It was so cold that alligators got frozen into a North Carolina swamp. That stubborn pattern persisted for weeks, and the extreme cold and heat got worse and worse.
You can see why meteorologists are calling it a bomb cyclone.
Bomb.
It's called bombogenesis. This is the current jet stream pattern. Does it look familiar? It's the Arctic air driving so far south that it meets up with ocean air. The Gulf Stream is warm, humid air.
While on the research cruise, the jet stream sent the bomb cyclone up to the Arctic, and we got a wallop. But then we enjoyed temperatures that were almost pleasant. At times 20 degrees above average and warmer than those in New York City. A week later, the jet stream brought extreme cold to Asia. Russia and eastern China were pounded with frigid cold. Tokyo had its coldest day in 48 years. While scientists scramble to understand how the Arctic may be intensifying the weather, some prominent climate researchers are skeptical. Scientists can't definitively say whether any one weather event was caused by the warming Arctic, conditions elsewhere, or by random chance. But Francis and others think the warming Arctic is loading the dice for extreme weather.
We can confidently say that some amount of the increase in extreme weather that we're seeing is because of climate change. This is not a question anymore.
One thing is for sure, extreme weather in North America is occurring more often. When the Arctic is very warm, very cold temperatures in the eastern side of the United States are likely. Climate scientists have given this phenomenon a new name: warm Arctic, cold continents. We tend to think of the Arctic as a victim of climate change, a canary in a coal mine. But the vanishing